Hello students, welcome you all to the next session, lecture 2 on control system engineering crash course. Today we'll be dealing with block diagram and signal flow graph. Let me introduce myself. I am SRAVAN Kumar, having 7 years of experience and mentored more than 5k students for GATE and engineering services and top GATE. And let me discuss the Unacademy learning app installation procedure before getting into the topic. Unacademy learning app बोल के टाइप करिएगा इन प्ले स्टोर, आपको दिखेगा installation process in step 2. Click on that. Then after that, just go to this GATE and engineering services if you are going to opt for that. Then click this plus sign and click the get subscription button so that you'll get subscription to that. And you can choose either plus or iconic. The specialty of iconic is you'll get a dedicated mentor for your preparation. You can also use my code as YSK10 to get 10% discount. And you also have many options of payments as debit card, EMI, UPI से पे कर सकते हो, wallet से या net bank से पे कर सकते हो. You can use any of these payments and get the subscription done. As we discussed earlier, we are dealing with the first chapter of the introduction to control systems, and these were the different topics that we have seen yesterday. And today we'll be dealing with इलेक्ट्रिकल मैकेनिकल सिस्टम्स, ब्लॉक डायग्राम और सिग्नल फ्लो ग्राफ के बारे में पढ़ेंगे. कल जो मैं बोला ना कंट्रोल सिस्टम्स के बारे में, टाइप्स ऑफ कंट्रोल सिस्टम्स, ओपन लूप कंट्रोल सिस्टम, क्लोज्ड लूप, फीडबैक, ये सब हमने कल कर लिया. एंड टुडे विल बी डीलिंग विथ मैकेनिकल सिस्टम्स, ब्लॉक डायग्राम रिडक्शन टेक्निक और सिग्नल फ्लो ग्राफ एंड मैसन्स गेन फॉर्मूला. चलो, लेट मी टेल यू द टॉपिक्स फॉर टुडे. मैकेनिकल सिस्टम्स पढ़ेंगे आज, ब्लॉक डायग्राम रिप्रेजेंटेशन के बारे में पढ़ेंगे और सिग्नल फ्लो ग्राफ के बारे में पढ़ेंगे हम. चलो, मैकेनिकल सिस्टम्स. कल हमने देखा कि व्हाट मैकेनिकल सिस्टम्स आर एंड व्हाट आर द डिफरेंट टाइप्स ऑफ मैकेनिकल सिस्टम्स, लाइक ट्रांसलेशनल मैकेनिकल सिस्टम एंड रोटेशनल मैकेनिकल सिस्टम्स देखे थे हमने. So in this translational mechanical system and rotational mechanical system, the first thing is to know this is mechanical translational system, and for any system you have an input as well as an output. And for a rotational system as well, you have an input as well as an output. हमें ये पता होना चाहिए कि ये मैकेनिकल ट्रांसलेशनल सिस्टम्स की इनपुट क्या है और आउटपुट क्या है, एंड मैकेनिकल रोटेशनल सिस्टम्स की इनपुट क्या होता और आउटपुट क्या होता, सो दैट you'll be in a position to write what is the transfer function of this system and what is the transfer function of this system. We have already defined what is a transfer function. Transfer function ये होता है कि Laplace transform of output और Laplace transform of input की रेशियो होती है. And so you need to know what is the input and output, और इसके Laplace करना पड़ेगा. Then you have to take the ratio of these two so that you can define the transfer function. The very first thing in any of the system is you need to know what is the transfer function of the system. So उससे जानने के लिए आपको इनपुट और आउटपुट जानने की बहुत ज़रूरत है. So input and output, what is the input and what is the output for a translational system, and what is the input and what is the output for a rotational system is very important. So for a mechanical system, force will be the input and displacement would be the output. और rotational systems में torque will be the input and angular displacement would be the output. तो हम इसकी अगर Laplace transform ले ली ना, so it is f of s, और इसकी Laplace transform होगी x of s, और यहाँ पे transform होगी t of s, और output की transformation होगी theta of s when you take into Laplace transform. So अगर आप देखें तो What is the transfer function of this? Laplace of output, that is x of s by Laplace transform of input, ये है f of s. For a mechanical rotational system, if you see, the output is theta of s and the input Laplace transform is t of s. So these are the transfer functions corresponding to mechanical rotational as well as mechanical translational systems. समझ में आ गई? Hope you got these points. Now let's see once again. I'll just try to revise what we have done here. Now चलो देख लो, फिर से बता रहा हूँ. So we need to know what is the input to mechanical translational system or mechanical rotational system. We also need to know what is the output for mechanical translation system and mechanical rotational systems. So for a mechanical translational system, the input is f of t and the output is x of t. For a mechanical rotational system, input is torque and the output is theta of s, so that you will take the ratio of these two. I hope I am audible. कोई मुझे बता दे कि I am audible or not, or if there is anything that is clear or not. If you can just text a message in chat, I'll understand if you are able to understand this concept or not. See, बहुत आसान टॉपिक है. It's a mechanical system, rotational and translational system. It's a very easy topic which you can learn it very easily. So I want you to concentrate and understand this topic. Hello sir Satish. Yes audible. अच्छा चलो. सो हम पढ़ रहे हैं कि मैकेनिकल सिस्टम्स के बारे में, मैकेनिकल ट्रांसलेशनल सिस्टम और मैकेनिकल रोटेशनल सिस्टम्स के बारे में पढ़ रहे हैं. एंड आई हैव टोल्ड यू ट्रांसफर फंक्शन, द ट्रांसफर फंक्शन इज सो इज इट इज ऑडिबल राइट? बता दो कि ऑडिबल है कि यस. महेश कुसुमा यस सर ऑडिबल. नीतीश मरनेनी यस सर यस. अच्छा चलो. सो क्या कर रहे थे? वी वर डिस्कसिंग ट्रांसफर फंक्शन ऑफ मैकेनिकल ट्रांसलेशनल एज वेल एज मैकेनिकल रोटेशनल सिस्टम. ये x ऑफ s बाई f ऑफ s इज द ट्रांसफर फंक्शन ऑफ मैकेनिकल ट्रांसलेशनल सिस्टम है, और थीटा ऑफ s बाई t ऑफ s इज द ट्रांसफर फंक्शन ऑफ मैकेनिकल रोटेशनल सिस्टम्स. समझ गए इतनी बात को? और नाउ what are the different elements in a translational system and what are the different elements of a rotational system? You have a mass, स्प्रिंग, ए डैम्पर और ए डैशपॉट होगी इसमें. और इसमें जो होगा रोटेशनल में इनर्शिया पिक्चर में आएगी, और डैम्पर और ये स्प्रिंग. एंड यू नीड टू नो द बैलेंस इक्वेशंस फॉर देम. There are some equations corresponding to them. Because it's a crash course, we are not getting into details of them, but I'll write, if you have a mass to which if there is some force is applied to this, and because of that if there is some displacement, हम फोर्स को क्या लिखेंगे यहाँ पे? इफ यू कैन राइट दिस फोर्स F as F force due to mass is, it is F is equal to mass m into d square x by dt square. This is the expression for mass, force due to mass. And if you have a spring on which if the force is applied, if it is displaced by some distance x, force due to स्प्रिंग की डिनोशन है k, और k fk is equal to k into x. Similarly, if you want to write for a dashpot or a damper, if you are applying some force to this, and because of that if there is some displacement, and this is generally denoted by b, or you can also denote it by f. So if you write force due to dashpot, it is b into dx by dt. There is something like Newton's law, Newton's second law, which states that actually if you have any body, the applied force on it is always equal to the opposing force on it, or algebraic sum of all the forces on a body is equal to 0, or the sum of applied forces is equal to sum of opposing forces. राइट, आई थिंक यू आर क्लियर विद दिस. चलो एक बार फिर से देखते हैं. ट्रांसलेशनल सिस्टम में थ्री, you have three. One is mass, the other one is spring, other one is dashpot, and the mass force due to mass is m d square x by dt square, or force due to k or spring is k into x, or force due to friction is b into dx by dt. And by Newton's second law we can say the applied forces is equal to opposing forces. Sum of applied forces is equal to sum of the opposing forces. So we can write, चलो लिखते हैं ट्रांसलेशनल के बारे में फिर से, एंड रोटेशनल की इक्वेशंस भी लिख दूंगा यहाँ पे. फोर्स ड्यू टू मास इज m d स्क्वायर x बाई डी टी स्क्वायर होगी, और फोर्स ड्यू टू स्प्रिंग होगा k इंटू एक्स, और elasticity we can say force due to b जो होगी b into dx by dt. if you have a change of displacements, और मैं रोटेशनल के बारे में नेक्स्ट स्लाइड में बताऊंगा. अभी इसमें if you have, let's say you have a mass, sorry, let's say you have a spring which has displacements, two displacements, so you can write displacements on both sides. You can write k into x2 minus x1, where x2 x1 are the displacements on the both ends. Similarly, if you have m, if you have friction because of which there are two displacements, you can also write it as x2 minus x1. And ultimately I'll take one example and tell you, say if this is a body and if there is some applied force, let us say the applied force here is f of t, और जो opposing force होगी ना, और opposing forces है because of mass, because of elasticity, and because of friction. And this Newton's law states that sum of the forces is equal to 0, or sum of the applied forces is equal to sum of the opposing forces. अब जब हम लिखेंगे ना, we can write it as f of t is equal to fm plus fk plus fb. Why? Because f of t is the applied force, fm, fk and fb are the opposing forces. I think this is clear. Are you able to understand this? मास की इक्वेशन क्या होगी? m d square x by dt square force due to mass, और opposing force due to mass is m d square x by dt square, and opposing force due to elasticity is k into x, and opposing force due to friction is b into dx by dt. चलो देखते हैं रोटेशनल के बारे में. Let's consider the mechanical rotational system. अगर हम देखें ना रोटेशनल सिस्टम्स के बारे में, you have a rotating part like this, which I told you as an example of a fan. You can also take a fan as a rotational system example. This is one example of rotational system wherein you have a rotating body which will rotate with some angle theta. हर एक रोटेटिंग बॉडी को ना इनर्शिया बोल के होगी. व्हाट इज दैट इनर्शिया? इट इज डिनोटेड बाय जे. इट इज denoted by J inertia. So if you apply some torque बोलो तो twisting force, two forces applied in opposite directions is a torque. So torque due to that inertia is given by J d square theta by dt square, or this is torque due to inertia, and torque due to spring is given as K into theta, and torque due to friction is given as B into d theta by dt. And next, if there is again a rotation on both sides, you can take Tk is equal to K into theta 2 minus theta 1. Theta 2 is the angular displacement on one side and theta 1 is the angular displacement on the other side. You can also write B d by dt of theta 2 minus theta 1. Alright. And as Newton's law says again, sum of the torque is equal to 0 or applied torque is equal to opposition torque. Right. So this is same as the translational system, except that you have this inertia concept. You'll have a mass in place of this inertia in translational system, and there is inertia in rotational mechanical systems. I think you are able to understand this, and if you have any doubts you can clear them off with these concepts. Now just we'll look back the translational system equations for mass, elasticity and friction, and for rotational system these three. Now let's solve a problem based on this. So consider this system that is given, obtain the differential equations, or you can also sometimes this is one question that is previously asked in your question papers in one of the universities. This is one question wherein it's given that this is a rigid part and you have K1 as the constant spring constant, B is the dashpot, and F of t is the force applied here, and this is mass m1 and this is mass m2 और ये है k2. यहाँ पे mass 1 की displacement जो है ना यहाँ है y1 and mass 2 की displacement जो है ये है y2. Let us say there is one more question here. It is not only to obtain the differential equation, he is also asking us to find, determine key y2 of s by f of s, or he may also ask you a question in the other way like find the transfer function of given mechanical system. This can also be the question. I'll tell you step by step कैसे इसको solve करते हैं. How do you solve this step by step I'll discuss with you. Just be with me, be live and concentrate so that you'll understand this very easily and you will be able to answer this any question that is based on this mechanical translational system very easily. So the first thing that you need to do is, when you are trying to write the solution, the first thing that you need to do is you need to know something called as a free body diagram. Free body diagram is drawn, which is drawn for each and every mass that is given. Here you have two masses, so you'll have two free body diagrams, which represents the forces acting on them. चलो देखते हैं. What are the different forces acting on mass 1? See, there is one applied force. Let's take this applied force in this direction. This is F of t. And whenever there is applied force, there are already opposing forces to this. If you observe to M1, there is a spring constant K1 that is attached. There is a dashpot. This is elasticity and this is friction that is attached. There is also other one K2 which is between mass 1 and 2. So what are the total forces? There is other force which by its virtue it is force that is opposed by mass, and force that is opposed by K1, force that is opposed by friction, and force that is opposed by the second spring constant or the spring. So this is about the first body. Now when you are looking at the second body, there is no force that is applied, then the opposing forces would be force due to mass 2 and force due to spring. Now from this would be the first step, and second step that you need to write is algebraic sum of all the forces acting on a body is equal to 0, or sum of applied forces is equal to sum of opposing forces. Sum of applied forces is equal to sum of opposing forces. Now let us take to the next slide. Now if you look at this, you can write from this, you can write what is the applied force. The applied force is f of t. So you can write f of force due to mass, force due to spring constant, force due to friction, and force due to the second. Now f of t is as it is, and force due to mass it is m. If you look at the displacement of the mass 1, it is mass 1, and the displacement here is y1. So you need to write m1 d square y1 by dt square plus k1 is the spring constant k1 and displacement is same as y1. So it is k1 into y1 plus b is b into, if you can see, b is between this rigid and mass 1. So you can write b into dy1 by dt plus k2. Now if you observe this k2, which is between masses 1 and 2, there are two displacements corresponding to this y1 and there is other one y2. So as I already told you earlier, you need to write k2 into y1 minus y2. This is all about the mass 1 for mass 1, that is mass m1. Now if you are looking at the second one, that is for mass m2. Now there are no applied forces, that is 0. What are the opposing forces? It is fm2 plus fk2. So 0 is equal to fm2 can be written as m2 d square y2 by dt square plus k2, it is between m1 and m2 and the displacements are y2 and y1. So it is k2 y2 minus y1. So this is the first equation and this is the second equation. Right, now you need to take, this is what the question is asked. Actually the actual question is obtain the differential equations. So these are the differential equations. You can write it as 1 and 2 are the differential equations corresponding to that. Or if you were asked to find the transfer function of the system, then you need to take the Laplace transform. Let us try to take the Laplace transform for this. So the Laplace transform for this would be f of t Laplace transform is f of s, and this Laplace transform is m1 s square y1 of s, neglecting the initial conditions because we are trying to find the transfer function, and this is k1 into y1 of s plus b into s into y1 of s plus k2 into y1 of s minus k2 into y2 of s. This is the Laplace transformed equation of the first one. What are we applying here? So we are applying Laplace transform. So apply Laplace transform. अगर यहाँ पे आ गए तो you can also apply Laplace transform to this. Let's take this to the next one. Now apply Laplace transform to this. Apply Laplace transform. So that would be 0 is equal to m2 s square y2 of s plus k2 into y2 of s minus y1 of s. So from this equations, let us call this equation as the third equation and this as the fourth equation. When you solve these two, solve third and fourth equation, you can determine what is the transfer function y2 of s by f of s. It's best just by simplification you can do this. So you have f of s in this and y1 of s, y1 of s, y1 of s, y1 of s and y2 of s. So but the equation must be, in order to take y2 of s by f of s, the equation must only be in terms of y2 of s and f of s. There is extra y1 of s, so you can find y1 of s from this equation. From this equation you can determine what is y1 of s. So if you are trying to write what is y1 of s, let's try to write that 0 is equal to m2 s square y2 of s plus k2 y2 of s minus k2 y1 of s. Now if you are writing y1 of s is equal to, you'll get something like m2 s square y2 of s plus k2 y2 of s by k2. So you have the coefficient here. So this is k2. Now substitute this, let us call this as fifth equation. Substitute 5 in 3. And if you take the third equation here, this is the third equation. You can substitute y1 in this, the one that we got here. You can replace that by this y1 by the equation that we got. So this is y1 of s. Replace this y1 of s in this. So this will be in terms of f of s and x y2 of s. So by that you can find the transfer function y2 of s by f of s simply. So this is how you'll find the transfer function is just a simplification, small simplification that you can do it very easily. This is a procedure that you need to understand. So let's try to understand this problem once again. The very first thing that you need to do is first when you are given a question, first try to understand how many masses are there in the question, how many masses are given in the question, and then write the free body diagrams, draw them, and then try to apply Newton's second law and then get the differential equations that you have seen here, then try to simplify them and get the transfer function that you need. So this is about the transfer function of a mechanical rotational translational system. Now let us take the other question, the second one. Obtain the transfer function of the mechanical system given. The first thing that you need to understand, here it is not specified whether it is mechanical translational system or mechanical rotational system. It's very simple. If at all you have masses, it is mechanical translational system. If you have inertia, you can simply say that it is mechanical rotational system. So Karthik Jilla, now my doubt got cleared, sir. Before I had a little confusion at this point. Thank you. SR, good evening, sir. Good evening. Harshit Kotla. Yes, sir. Okay. Thank you. Very good, Karthik. So let's try to find the transfer function for this. I'll tell you the method to determine the transfer function for the given. The first point is the given transfer function is a mechanical rotational system. It is a mechanical rotational system. So it is a mechanical rotational system. The second point, you need to know what is the input of the system and what is the output of the system. So you can there is applied torque and there is the output. So here also you need to draw the free body diagram for both inertias J1 and as well as for J2, right? So whenever you look at this, there is some applied torque to this. This is the applied torque, and opposing torque should be represented in the opposite direction. It is the opposing torque due to inertia, and there is an opposing torque due to spring. And for second inertia, there is no applied torque directly, so it is 0. And for it has a spring which is in the opposite direction, there is another dashpot which is opposing it. This is drawing that free body diagram. Next step is, you already know sum of the torques is equal to 0 on a body, or applied torque is equal to opposing torque. So for the first case we will write TA is equal to TJ, torque due to inertia, and torque due to spring. So what is TA? TA is the applied torque. What is TJ? It is J into d square theta 1 by dt plus Tk is K into, it is corresponding, it is between J1 and J2, so you must write it as theta 1 minus theta. So you can take the Laplace transform to this, then we will write the balance equation, torque balance equation for the second J2. So there is no applied torque and the opposing torques are TB and TK. चलो लिखते हैं B क्या है, it is TB, it is connected between these points, so there is only one angular displacement, so it is B d theta by dt, or K is, as we have seen already, it is connected between two, so it is theta minus theta 1. So you can take these two equations and take the Laplace transform of them and determine the transfer function. That's very simple. You can take these two equations. चलो लिखते हैं, we'll try to do that also for this problem at least. Yeah. Yes. Now we'll take the Laplace transform to this. What is the Laplace transform to this equation? It is TA of s is equal to j into s square into theta 1 of s plus k into theta 1 of s minus k into theta of s. And if you take the Laplace transform to this, it is 0 is equal to b into s into theta of s plus k into theta of s minus k into theta 1 of s. We need to find the transfer function as theta 1 of s by TA of s, applied torque. I'm taking it as TA of s. So you can just replace, you need theta 1 here, so you only have theta of s in this equation. So you can replace theta of s here with this equation. So let's try to find theta of s from this second equation. So theta of s, now if you take theta of s common here, it is bs plus k. So you can take k into theta 1 of s by bs plus k. K into theta 1 of s by bs plus k. Substitute this in the first equation. I'll just write clearly once again. Yeah, this is 0 is equal to b into s into theta of s plus k into theta of s minus k into theta 1 of s. Now we are trying to find theta of s from this. So let's try to take theta of s common in first two terms. It is bs plus k minus k into theta 1 of s. Try to find theta of s from this. Theta of s is equal to k into theta 1 of s. Taking this term to the left hand side, it is bs plus k. Consider this as 1 and this as 2. Substitute 2 in 1. So Ta of s is equal to js square theta 1 of s plus k into theta 1 of s minus k into theta of s. You have theta of s here. Replace that with this theta of s. So it is k into theta 1 of s by bs plus k. Now take common this. This is Ta of s is equal to, take common theta 1 of s in this. It is js square plus k minus k square by bs plus k. So with this, from this you can write what is theta 1 of s by, sorry, so you can write what is theta 1 of s by Ta of s. It is 1 by this whole thing. So this is the transfer function required. Hope this is clear to you. Mechanical rotational system. So let me review what we have done. For the given mechanical rotational system, we have first identified whether it's just given it is a mechanical system. This is also one of the problems given in one of the university examination semester examinations. Now to obtain the transfer function of this, first you need to identify it is a mechanical rotational system. और input और output क्या है लिखना पड़ेगा. Then you need to write the Newton's second law and draw the free body diagrams and write the differential equations. और इसके बाद में उसको Laplace transform करने पड़ेगा. As you can see, we have done Laplace transform. Then you need to simplify the two equations such that we can find the transfer function. Now I can understand, sir. Ramchandra Kumar. Thank you. Anup Sagar. Yes, sir. Clear. Awesome explanation. Thank you. So that was about this mechanical rotational system. Now, the next topic is block diagram reduction technique. You need to understand some of the rules in this block diagram reduction technique. Then you will be able to solve a given question. The questions will be something like this. This is one of the question given in one of the university examinations, that is convert the given block diagram to a signal flow graph and determine C of S by R of S. First we'll try to solve this by using block diagram reduction technique, and then we'll also try to solve this by using converting it to signal flow graph as well. चलो पहले हम समझते हैं what is this block diagram reduction technique. It is a method that is used to, it's a method, sorry, so this is a method to find transfer function by using a set of rules. ये rules क्या है आपको पता होना पड़ेगा. And before that you need to know some of the other things as well. Let us consider this. Let me take this block diagram. So this is a block diagram. Let us consider what are all these called as, that you need to know. I have given it here. I'll also tell you here as well. चलो क्या ये, this is input. You need not know this, but you need to know this. This is called as summing point, and this point is called as takeoff point or pick off point. Here you'll have the output. That means from where you are taking a signal and giving it back to the input, you're taking a part of the signal, right? So it is called as a takeoff point. So this is generally G of S and this is H of S. So sometimes what happens is you may not be able to apply these set of rules. So you need to apply some of these rules to simplify the given circuit. For example, there is a first rule: if they are in series, if the two blocks are in series, let us say G1 is one block and G2 is the other block. You can replace this by simply writing G1 and G2. As in electric circuits you do, if you have two resistors, you just simply just simply write it as series of the resistors is R1 plus R2 and parallel of the resistors is R1 R2. 1 by R is equal to 1 by R1 plus 1 by R2. The same. Now the second one is, if they are connected in parallel. Now let us say there is a block. You can also call this as cascade instead of series. There is a summing point. This is the summing point to which you are giving two signals from G1 and G2, and this depends on the sign that is given here. If this is plus and this is minus, you will write it as G1 minus G2, or this is also plus, you will write it as G1 plus G2, but the signal direction should be towards this summing point. Next, third one. Suppose there is something like this G1 and you have a G2 block, and there is something like this that is given, let us say G3. But we know that if there are two blocks in series or cascade, you can directly write them as G1 G2. But there is some signal that is taken from here. So what we can do is, instead of putting this point here, we can shift this point to this point. Let us say this is point A, this is point B. You can shift from A point to B point, so that this will become G1 and G2 in cascade, and you can take this signal from here. But in order to shift this point is called as nuff, this point is called as takeoff point. So in order to shift this takeoff point, the signal that is coming to this G3 or going away from this G3 must not change. So that should be followed. In order to do that, what we will do is, so you have, let's say, a block G1. There is some takeoff point. Let's say this is A, and here the signal will be AG1, the output of this. So what you'll get here, if you are taking out this point, this is AG1. Now if you want to change this, that means you are moving this takeaway point before the block. So let's say there is some G2 here, so you want to move this to the left side. That means you are moving the takeoff point before a block. So this is G1, this is A again, this is AG1. Now if you are moving this to this point, the takeoff point, now what is the signal to this takeoff point? It is A, not A into G1, but previously it is AG. But when you want to move this from this point to this point, the signal here has become A. So but whenever you move any point, takeoff or summing point, this AG1 must not change. So in order to compensate that, we will multiply with a block G1 here. So here what do you need to understand? When a takeoff point is moved from after block to before block, then we need to multiply by the gain or the block. This is the takeaway from this. Now similarly, let us consider the reverse order. If you have G1 here there is some signal A, and there is already a takeoff point here, and here there was a block G2 for example, and you want to multiply this G2 and you want to move this after the block. Now let us say you want to move this to this point. Now what is the input here? What is the signal here? A. Now when you move it after the block, the signal should not change. So I am moving it after the block. So this is A, and now this will become AG1, and I have moved this after the block. I have moved the takeoff point before to the after the block. Now what is the signal to this? This is AG1, but previously the signal is A, so it should not change. So what we'll do is we will multiply this by 1 by G1. So whenever you move a takeoff point after a block, it should be multiplied by 1 by the gain of the block. And whenever you move a takeoff point before the block, it should be multiplied by the gain of the block. Similarly, whenever you have a summing point, let's say there is a summing point here, and you have an input, and there is some G, there is some summing point here, and this is A, and this is B. And what is the input to this now? A plus B. Let us say these are plus, then this is A plus B. What is the output of this? A plus B into G1. Now if you try to move this summing point, similarly as I told you, you have another block here, and let us say you want to cascade it with G1, and you want to move this summing point to the right side or after the block. Then Haima Ketavarapu, good evening sir. Good evening Satish. Use different nice. Vasu, sir, made complicated things too simple. Cleared my doubt. Thank you. Good evening. So this is now when you want to shift the summing point to after the block, this is G1, and you are moving the summing point to this. Now let us say this is the input to the signal, and it is AG1, and you are moving it after the block. Now whenever you want to move it after the block, and you give this, if this is plus, sorry, and if this is plus and this is also plus, you'll get it as AG1 plus B. But the output here is AG1 plus BG1. But here it is AG1 plus B. So B must also be multiplied with G1. So you will place a block G1. Similarly, if you want to move from left to right to left or before the block, this is moving. This rule is called as moving after the block. And this, the if you want to move after the block, it must be multiplied by the gain of the block. If you want to move before the block, it must be multiplied by 1 by gain. These are some of the points that you need to remember, and with this idea we'll try to solve this given block diagram. Now whenever you observe this block diagram, if you observe this block diagram, you can easily identify that you can cascade G1 and G2. You can easily identify that you can cascade G1 and G2. But there is some takeoff point that is interrupting to cascade these two. So what I'll do is I will move this takeoff point before the block. And you need not remember all the rules that we have studied. You can just simply look at this and understand. Now I'll draw this. Now I'm shifting this takeoff point before this. Now there is some block here as well, which is G3. This is minus and this is plus. You need to be very much careful about this plus and minus signs. And C of S, this is R of S. With this idea of block diagram that we have seen, let us solve this. So this is already G1, this is G2. Now I'm moving this takeoff point before this. That means the takeoff point has come here. This is H. So this is the takeoff point. Now, but the signal that is coming to this, let us forget about everything. There is something coming from G1 you are taking. That means G1 is also being multiplied with this H. But when you move to this point, G1 is not included. So what you need to do is, you must include G1 also. This is H, and there must also be some G1. This is G1. So this is nothing but moving a takeoff point before the block. Now you can see these two are in cascade. You can multiply them and just simply write it as HG1. So write it as H into G1. Now if you see these two, G1 and G2, both are cascade. So you can replace that. And because they are cascade and we know the cascade rule, it is G1, G2. And if you observe these two, this is towards the summing point, this is also towards the summing point, this is plus and this is minus, and both are said to be in parallel. So you can replace this whole term, you can replace this G1 G2 plus and G3 is minus. So you can replace G1 G2 minus G3 simply. So you can replace this by G1 G2 minus G3. And if you look at this, this is actually a feedback path, which there is some negative feedback here, it is minus and here it is plus. So if you have a negative feedback, just remember you need to take G by 1 plus GH, and if it is a positive feedback, take 1 minus GH. Now because it is a negative feedback and there is nothing given here in the forward path, so let us consider it as 1. So you can replace this by, so you can write this as 1 by, because G plus, because it is minus, you need to write plus H into G1. So you can replace this block by simply writing G is again 1 into H is HG1. Now if you observe these two are in cascade again, you can simply just multiply these two like this and write the transfer function. So the transfer function is C of S output by R of S is equal to G1 G2 minus G3 by 1 plus H G1. This is the transfer function corresponding to the given block diagram. You can also convert this into signal flow graph and find the transfer function. Signal flow graph is one technique that uses Mason's gain formula. So signal flow graph. Let us now, this was block diagram. Once I discuss about signal flow graph, we'll take the same circuit and try to we'll also take the same circuit or the other circuit as well. There are two circuits and we'll try to find the signal flow graph for the given question. Now signal flow graph. This is a easiest method of finding the transfer function, wherein you'll use Mason's gain formula. Mason is the name of the scientist. He has given a formula to find transfer function. This is transfer function T of S is equal to 1 by delta sigma pk delta k. This is the expression given by Mason's to find the transfer function of any given signal flow graph or block diagram or a system. For a system, you can draw the block diagram or you can convert the block diagram to signal flow graph, and from the signal flow graph and block diagram you can determine the transfer function. If you observe the block diagram reduction technique, अगर देखे तो आप block diagram reduction technique में actually I have done it on screen, so it was very easy, but it is a very tedious process. You need to every time draw the block diagram, and if this is a very small diagram that is already given in your question paper, but if there is a very big circuit or a system which has many number of gains blocks, and if you are asked to find the transfer function, it will be a very tedious process, doing step by step, applying different rules to this block diagram. So it will be a very tedious process. In order to save that time and energy and calculations and confusions, Mason has come up with some formula which is transfer function is equal to, or you can also write it as C of S by R of S. Generally it is written as is equal to transfer function is equal to 1 by delta pk delta k. You have some k is k and p and delta. You need to know what are these things. P, number of forward paths, delta and delta k, you'll find it. What is delta is, it is 1 minus number of individual loop gains plus, it's not just the number, sum of the individual loop gains and plus sum of product of two sum of product of gain of two non-touching loops, and similarly minus sum of product of three non-touching loops. We'll see what are these non-touching loops and all. So this is an expression that is given. So you need to find the transfer function by using this expression. So in the next session we'll see how to solve the signal flow graph by using Mason's gain formula, by using this Mason's gain formula expression. So it is P is also the forward path gain actually. So you can take k as the number of forward paths and p is the forward path gain of the forward path. Two forward paths, you'll have path 1 and path 2, and you need to write the gain of this forward path, and you also need to write the gain of the forward path. I'll tell you what are these gains of the forward paths as well. So Mason's gain formula is T of S is equal to 1 by delta sigma pk delta k, where p is the gain of the forward paths and delta is 1 minus sum of gains of the individual loops plus sum of product of the gain of the two non-touching loops plus sum of product of three non-touching loops taken three at a time, and so on. So we'll try to solve this by using signal flow graph, this section also. So coming to India's #1 study channels, Creatrix, GATE Electrical EC and Instrumentation, Unacademy, GATE MEPI and XC, and we also have Unacademy GATE CE, Unacademy GATE Telugu, Unacademy SSC JE, Unacademy Computer Science, Unacademy GATE Questions, Electrical Junction, Unacademy Engineering Foundation, and Engineering Pathshala. You can also use my referral code YSK10 to get 10% discount. Please do like and share and subscribe to this. And I hope you got something about mechanical translational system and mechanical rotational systems. We have what is mechanical translational system and mechanical rotational system, along with an example, and what is free body diagram. Also we have seen what are the rules of block diagram reduction technique, and solved a problem based on them. So these are the takeaways from today's session, and I thank you all for joining me today on this session. We'll have the continuation of this session with signal flow graph and the next topics also. So uh, join me at 6:45 tomorrow. Thank you all.